The differential equation first came into existence with the invention of calculus by Sir Isaac Newton. He proposed three types of differential equations. Later on, many mathematicians like Bernoulli, Euler, Lagrange solved numerous problems that involved differential equations. So, let me tell you why we are supposed to learn the differential equation, and what's the application of the differential equation in our daily life. Differential equations occur in connection with numerous problems that are encountered in the various branches of science and engineering. Like, the problem of determining the motion of projectile, rocket and even planet, involve differential equations. The problem of determining the current flow of an electric circuit, vibration in a string of guitar or membrane of the body, even in chemical reaction involve differential equation. It would take whole day, but unfinished, to speak about all applications of differential equation. So, let's get into the topic. Before starting the core, you should know the basic first. So what is differential equation? Ask yourself, do you actually know that? Well, I am here to clear your basic about differential equation. So, here it is. A differential equation is a relation connecting one or more independent variables with one or more dependent variables and their differentials. So, it's just a combination of x, y and the differentials of y with respect to x. These are some examples of the differential equation. As you can see, in the first two examples, x and t are the only independent variables respectively, and y is the only dependent variable. But in the last two examples, there are 2 and 3 independent variables, which are x, y, z, respectively. So it is clear that the various variables and derivatives involved in a differential equation can be occurred in a variety of ways. So we must classify them. To begin with, there are two categories of differential equation. One is ordinary, and the other is partial. In the case of ordinary, there is only one independent variables. But when a differential equation contains partial derivatives of one or more dependent variables, with respect to more independent variables, then it is called partial differential equation. Remember, partial differential equations have more than one independent variables. Now what is degree of the differential equation? It is the greatest exponent of the highest order derivative. Of course, it has to be rationalized, as far as the derivatives are concerned. Based on degree, we can categorize the differential equations into linear and nonlinear. When, in an ordinary or partial differential equation, the dependent variable and its derivatives have the first degree only, and not as higher powers or products, then the equation is said to be linear, otherwise it's a nonlinear. See these two examples. They are linear because there are no higher power of derivatives or of dependent variable y. If x has higher power, it doesn't matter. Now look at these examples of nonlinear equations. Because of the term y square, the first equation is nonlinear. In second example, there is a higher power of derivative. And at last one, there is product between y and its first order derivative. That's why they're all nonlinear. Now, let's talk about solution of the differential equation. Any relation connecting the dependent as well as the independent variables will be called the solution, or primitive of the differential equation. Now solution of differential equations can also be divided into two parts. One, complementary part, and other is integral part. But I will explain about them next time, with problem-solving samples.